With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
The question is, the frequency and intensity of a light source are both doubled. Consider the following statements. First statement is, the saturation photocurrent remains almost the same. Second statement is, the maximum kinetic energy of the photoelectrons is doubled. Options are both A and B are true, A is true but B is false, A is false but B is true, or both A and B are false. So the frequency and intensity of a light source are doubled. So let's say initially this light source was emitting n number of photons. Let's say n is equal to number of photons. And this is constant. We are treating this as constant. We know intensity is equal to power per unit area, and power, what is power? Work done per unit time, so we can write it as W by T into A. And what is work? Work is energy, and what is energy here? E. But how many photons do we have? N, so Ne would be the total energy, dA. So if we write it like this, E is equal to energy of photon is equal to h nu by A. Okay, so and like we are doubling both frequency and intensity, but I'm saying that n is constant, so this term is constant. When we are doubling the frequency, this thing, what is photocurrent? Photocurrent is the number of electrons that are coming out, right, that are emitting out. So we can say this, if this thing changes, only then intensity would change, or we can say only then photocurrent, value of photocurrent would change, only when n changes. So when we are changing the frequency, this thing has, like, frequency has no effect on this thing, right? Because we're just changing the frequency of each photon. It's not like we are changing number of photons, so it won't have any effect on this, and we can say that photocurrent still remains constant. And now we are doubling intensity also. If we are doubling the intensity also, that means each photon is doubling its energy. It's not like they're doubling the number, it's like they're doubling their energies. Initially, if their energy was, if energy of each photon was, let's say photon 1, its energy was E, now it's changing it to 2E. In this way, intensity is doubled for each of the photons. So we say even when we double the intensity, photocurrent is still the same, saturation photocurrent will still remain the same, because number of photons is still constant. So the saturation photocurrent remains almost the same. A is true, so A is true. Now let's check the second statement, that is maximum kinetic energy of the photoelectrons is doubled. We know maximum kinetic energy is given by photoelectric equation, that is kinetic energy, maximum kinetic energy is equal to h nu minus phi, right? And now we are doubling the frequency. So let's say Ke dash maximum is equal to h into 2 nu, right, minus phi. So we can rewrite it as 2 nu minus, we can write phi as minus 2 phi plus phi, just to take out this 2 common, so we'll understand what is really happening. So 2h nu minus phi plus phi. What is this thing? Initial kinetic energy, so we can write it as kinetic energy max plus phi. So had this term been not there, like if this term wasn't there, then we could have said that the kinetic energy is like doubling its value, but we have 2 times kinetic energy maximum, that is initial kinetic energy, plus something. So plus something means it is like it's changing more than twice, right? So maximum kinetic energy of the photoelectron is not only doubled, it's like it is doubled plus some amount, plus some extra amount. So we can say this statement is wrong. So A is true but B is false. This is the right option.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.